Hello and welcome to another episode of Flying High with Flutter. I'm your host, Alan Wyma. And I want to just remind you guys to come to our website and sign up for we have some events coming up and some special things coming on. So please sign up for our mailing list. We'll be sending out some emails pretty soon about that. But now back to the main show. I have Connor Rigby on the show. I hope I said your name right. I'm sure that should be good. He is a software engineer at Binary Noggin. Now, the interesting thing is that he is not a Flutter developer, as maybe you guys may be used to over here. He is a Elixir developer, but more so using Elixir with nerves, which is like embedded development, which means he probably has to do a little bit of C and C++. I think he did some Rust also, maybe at least played with it a bit. But anyways, you can talk about more of that yourself, but just want to give a quick intro. But the reason that we bring you on is, of course, is to talk about, when you ported the Flutter engine. But yeah, let me just give a quick intro about yourself, talk more about who you are and kind of what brought you here.
Cool. Yeah, I, like you said, Connor Rigby, a generic software developer. I mostly do embedded stuff with like you said, a framework called Nerves. For like embedded devices, you might consider Raspberry Pi, BeagleBone, etc. Work for a company called Binary Noggin. We do software consultancy, kind of full stack stuff. All of the things that you would need to write or to get your application out into the world. Not a ton of Flutter. I'm still sort of learning it. I find it really interesting, but I haven't written a ton of actual Flutter code myself. I've been digging a little deeper than the actual Flutter itself, working with the engine and stuff like that, and been having a good time with it so far.
Yeah, so I think maybe we can start from the beginning. Like, what got you onto this whole project to begin with?
Yeah, so I worked with a company called SmartRent. They do smart home hardware and software. One of the new product that they were sort of developing or starting to work with is a smart thermostat. So, something you have on your wall that controls your HVAC, like heat and AC and such. They wanted to leverage like sort of the modern app development platform. So they were looking at like React Native and Flutter, of course, as their framework of choice for their UI on the device itself. So you can imagine you're sort of similar to like a Nest, if you've ever seen those before. The little screen on your wall, it's got a little dial on it that you can change and everything. So that was like sort of the first demo that I created once I got this all up and running, was just like a small thermostat, right? So just on the Flutter device, there's, a small screen that has a circle and the temperature on it, and you can change it and whatever. So yeah, that was sort of the original use case for all of my work. And it just has sort of bubbled up from there.
I mean, that's pretty interesting. Like, I'm just trying to think about where the heck would you even start to do something like this? Like, how did you even start this process?
That was sort of the hardest part, was getting started. As it turns out, UI development is like a whole thing that I wasn't so akin to. I don't even do web UI stuff that often. So jumping right into app development was like sort of a big jump for me, I suppose. It was an experience. A lot of it, the beginning, was just like scrounging GitHub, looking for anything that might like sort of help me. We sort of spent, Frank Hunleth and I spent probably maybe a week just collecting useful GitHub repos. So there are people that have implemented the Flutter engine in Go. That was a really useful one, even if I didn't really use much code from it. The concepts were all very well documented in that repository. I can't remember the name of it off the top of my head, but maybe we can throw it in the notes later. Another one was a project called Flutter Pi, which was some guy. He appeared to be a developer maybe with the Flutter engine, or maybe he worked at the Raspberry Pi Foundation or something, but he seemed very like intimate with the details of how the Flutter engine works. And he made this project Flutter Pi that was sort of exactly what it sounds like, a project to run Flutter applications directly on the Raspberry Pi. And that was sort of the biggest like jumpstart that we found in a lot of like the very first iteration of the Flutter engine that I wrote, or that Frank Hunleth and I wrote, was based upon that. And the original idea was actually just to sort of fork that project and maintain like a set of patches on top of it, because it really did do a lot of the stuff that we needed. Eventually we ended up not going that way, and we sort of had to like write it from scratch, but that was a really good place to jumpstart from.
That's a good point. Maybe we can kind of roll back a little bit and talk more about Nerves, right? Because I think you're probably on the core team, right?
I am,
for
yeah.
Nerves. So maybe we can talk more about what Nerves is, because that definitely makes sense about why you look at Raspberry Pi. Because when you say embedded development, people are usually thinking maybe Arduino or something really kind of low level, but that's not what Nerves is about.
Yeah, there's like a whole class of thought here. Some people get all really kind of up in the semantics of what embedded really is, and I'm not really here to get into it. But yeah, we do anything that runs Linux basically will be a good candidate to run Nerves. So like your Raspberry Pis, your BeagleBone Black. Arduino had a Linux-based device for a while. I think it was called like the Leonardo or something like that. Back in the day, we did support that. I don't think they support it anymore. The Arduino Foundation doesn't support it anymore, so we kind of dropped support for it. But yeah, there are a handful of other devices. Like there's a couple OSD systems chips that you probably have interacted with in your life, but maybe had never actually heard of. And yeah, so the whole idea is to have just the bare minimum of a Linux system to get up and running and booted into an Erlang VM with that runs Elixir on it. So if I don't know how familiar the user base is with Elixir, but it's just like a Ruby-esque type kind of shell around the Erlang programming language, which is like an old telecoms platform, and it just happens to work really well for embedded due to a bunch of its promises like soft real-time and resiliency and supervision and all those fancy things.
Yeah, I've talked quite a few times about Erlang and Elixir on here, and we had another guest on here who did an Erlang Elixir backend, and yeah. Actually, the funny thing is, I believe I don't know how much you know about Flutter and Dart, but have you heard of Dart's isolates before?
Isolates, is that what you said?
Yeah.
I've heard the concept. I don't know that I've ever actually used it in practice.
Okay. Yeah. They had this idea of an isolate, which is very similar to an Elixir process, where it's like a separate piece of kind of memory and nothing is shared. And you have to use these things called ports to send and receive messages. Mm-hmm. So, we had one of the creators of Dart on here, and he actually talked about it. And I believe he actually said it's actually inspired from Erlang too, this idea. But he said the only thing that's different is that you can't have like millions of processes like you can on Erlang,
right?
But millions of isolates.
Right. It's sort of interesting name they chose, ports. That's an Erlang concept as well. That's actually the Flutter engine that I wrote for Elixir itself is a port, which is sort of funny. So there's a bit of name spacing here, an Elixir or Erlang port, if you will. And basically all that is just like any external program can be a port in the Erlang world. And there's a special communication protocol that you can sort of specify that makes it so you can automatically get native terms in both formats, so your C and your Erlang.
Well, I mean, it's interesting to see that people are actually taking a look at Erlang and using it in designing more modern languages, right? Especially one with the weird history of Dart. I think you know about the history where it's kind of supposed to be a better version of JavaScript, I believe. And then now you have something totally different. So we never thought about something like that.
Yeah, that's how whenever I've been talking about this project to people and they're like, oh, if someone asks me like, what's Flutter? The way I introduce it is just like React Native, but everyone actually likes it. And so that's just sort of my little thing that I like to say. Yeah, that's how it feels like to me, is just Dart is like a more modern or more sane JavaScript, I suppose.
Yeah, we had another guest on here who's really big into React Native, and he didn't admit what I said was true, but at the same time, he was still pretty happy with it. And that's okay. I mean, if sometimes things work for people and it doesn't work for others. Like for me, Python is just a pain and I hate using it, but some people really love it and it works great for them. So what can I say?
Right. Yeah, I mean, to each their own, as long as everyone's happy using whatever their favorite tools are. Flutter itself has been like a really cool tool for me. I haven't got to use it for a ton of like real projects, but it's just been like kind of for a while I did like just native app development, like Android Studio, way back in like probably like the gingerbread ice cream sandwich days. That's when I was like sort of into that scene, and going from that was like my last app development experience to Flutter, which was like you run one command on your computer and then you have like, of course you got to set up ADB or like the emulator or whatever, and there's all that, but just like getting an application running on my device and like hot code reloading and stuff on it was just like a dream experience compared to what I was used to several years prior, I suppose.
Yeah, I totally agree. Like I've only had one computer out of like maybe 12 or so that I've helped install Flutter on that this didn't work for some weird reason. But other than that, like it's been an amazing experience and I'm super happy with it. But maybe let's kind of get back more to like the project at hand, right? So I'm really interested to hear more about like, I believe you said SmartRent asked you to work on porting it over, which is quite interesting. You got something working by taking a look at like the one in the implementation in Go. You also said you used a lot of the code from Raspberry Pi, which makes sense because I think you said they used BeagleBone Black or some kind of variation on it. From what I understand, like I think people don't usually, or you shouldn't be using, if you're going to do this kind of stuff with your custom board, you can't really use the one from Raspberry Pi, right? Because it's like copyrighted or something.
Yeah, there's a few different schools of thought on this, and I think it's kind of the same type of people that are saying don't put Arduino in production. So there's like a bit of a maybe grain of salt to be taken with that. I don't know. My last company, Farmbot, we used Raspberry Pi in production. They still use it today. It works fine. I think it's just as long as you know the limitations, you know what you're doing, it's not really as big of a deal. Raspberry Pi Foundation actually has a sort of a system that they want you to use to put devices into production. They call it the compute module. So it's like this little, I don't think I have one handy on my desk here, but it's just like a little board. The old one used like an old SODIMM, like the laptop memory sort of form factor. That's what it looks like. It looks like a stick of RAM that you might put in your laptop from 5 years ago. And so they basically produce that board, and then you design a carrier, or you have someone design a carrier that thing just slots into. So you don't have to worry about all of the there's like a bunch of stuff you have to worry about when you're designing a board. Like when you put memory on a board, you got to route the RAM, like the traces on the board. You have to route them specially, otherwise you'll get like crosstalk and stuff doesn't work, and you get like really weird stuff happening. And so they sort of abstract all that away from you, in the same way that in your software, like in Flutter, you don't have to worry about the engine underneath it. You just know that it's like this rock solid platform that you could start with. So yeah, the Raspberry Pi, they make a board that is similar like that, so you can sort of do it that way, or even just like the Raspberry Pi Zero or the Raspberry Pi boards themselves. You can put them into production. You just have to sort of know the limitations around it. A lot of people, when they are building their own devices, they're going to go with like a BeagleBone because it's a fully open source platform that you can actually go like look at the schematics for the BeagleBone Black, and they're open source, so you can modify them and work around them as well. So I think that's sort of more of a popular route these days, but the Raspberry Pi is just so cheap that it's hard to ignore, right? They're $5, so. I think they actually just raised their prices for the first time in existence. They're like 15 or so now, but yeah. When we started this project, we started on the BeagleBone, but the graphics stack on it is a little bit harder to work with than the Raspberry Pi. Raspberry Pi's got very good documentation around all of their graphic stuff, so it was sort of easier to get started with it than it was to do the BeagleBone Black. After we burned a lot of time just getting the screen to turn on the BeagleBone Black, which it just does that by default on Raspberry Pi. So.
All right, so you switched from there to Raspberry Pi. That makes sense because this is basically just a POC, right? That you're working on.
I would call it somewhere in between. Yeah, I think if you like, I don't know if SmartRent, the company that I was working with for this, I don't know if they're quite putting it in production yet, but I think it's really close to being something that you could put in production. I had a device sitting on my desk with an application running on it for probably like 2 or 3 weeks. And there was no, it didn't just randomly crash or anything. And a cool thing about the Erlang VM is that it's got the supervision guarantees. That's sort of its entire concept. So if for whatever reason you do manage to crash the Flutter engine, which is possible, it's pretty hard, but you can do it if you try really hard and sort of ignore the compiler warnings and start doing wacky stuff. You can get the Flutter engine to crash, but I guess the cool thing about it is you can use Erlang to just restart it whenever that happens, and it's pretty seamless. There's maybe a second of downtime where the screen goes blank and displays a big kind of wireframe error on the screen that Flutter is like, hey, what are you doing? Stop that, and then it just resets itself. So it's a pretty neat little setup.
Okay, yeah, I was actually more interested on more about the development, but I think I'm also kind of interested how this would even work. But okay, so maybe back to the core. So you got the engine basically running, and because you used Raspberry Pi, it was pretty straightforward because you already had the existing Flutter Pi, right, to work on.
Yeah, the project out there called Flutter Pi.
So how do you actually load the Flutter engine onto an existing Nerves device? Is that like an overlay or what is that?
Yeah, so I sort of fumbled around in my brain for this. A lot of the work involved here was setting up tooling for it. So of course you need to have Flutter installed on. So for one, I guess I should explain that whenever you're doing any Nerves work, you do all of your work on your host machine in the same way that when you're working on a Flutter application, you have all of your code on your host machine. You hit Control S and it syncs it over to your device. So we've got that same setup with Nerves where you've got your Nerves devices running and it's got your Flutter code on it. You hit Control S on VS Code or whatever. Well, I've only tried it in VS Code, but I expect that it should work anywhere. You save the file and it just automatically syncs it to the device, and you've got the code running on there, which is a really cool and really snappy thing. The debugger works. You can see all of the Dart VM sort of debug capabilities. That's all built in. It all works. VS Code's like the device browser widget thing that comes up on the side pane whenever you're doing Flutter app development. That all works perfectly. So how it works is in Nerves we've got this. There's you know how in Flutter you have the Flutter run command. There's sort of an analogous in Nerves. We've got this mixed firmware command that will build you this little bundle of code. It's got the Linux kernel. It's got a root file system, all of your Elixir and Erlang code, a bunch of C shims and stuff that all happens in under the hood for you to set up networking and all that sort of stuff. And then it also builds the Flutter engine and the little shim between the engine and Elixir that I wrote. And so all of that gets bundled up into this little firmware file. It's a .fw file. And you write that to an SD card via another command we publish. You can also use stuff like if you've done anything on Raspberry Pi, you've probably used a project called Etcher. It's just a write. It's a project to write image files to SD cards. So once you get it on the device, however, whatever method you choose to do so, you put the SD card in there, give it power, and it just turns on, and you've got your Flutter app running. And it's part of it's part of the Erlang supervision tree. So it just starts up as soon as the VM starts. And at that point, once your device is connected to Wi-Fi, or I use a USB, there's a thing called gadget mode, which basically makes the Raspberry Pi enumerate as a network device. So it gets an IP address and everything, and you can ping it at nerves.local. And so then as soon as the device is up and running, you hit F5 on VS Code, it just connects, and you can start writing away all your Dart code. And, it's like a really snappy, really fast development cycle. It's really fun, actually.
I'm still trying to think about when you boot this thing, because I'm so used to booting stuff using like Android Studio, where I click the play button and it kind of starts up. So actually you'd have to somehow attach to it in order to push new code, right?
Right. So
I'm just thinking about just the Flutter part itself.
Yeah, the Flutter VS Code extension has got like a command built in to attach to a running device. So it uses SSH under the hood. So Erlang has a built-in SSH server, which we use for Nerves all the time. So you can get a running console to the device. And so whenever a Flutter application starts up, it starts up a little HTTP server under the hood, and it just like randomizes, it picks a random port and to run the debugger on, and the observatory URL. So when you start a Flutter app, you'll see a observatory URL running at blah, blah, blah. So essentially, if you plug VS Code into that URL, you can just connect to any running Flutter device, as long as you can give it access to that URL. So essentially what happens is when you hit F5 or like run on your keyboard in VS Code, it pops up a little prompt that asks you for the VM, and you just paste it in there and it connects right away.
Okay, that makes sense.
Flutter has some stuff built in that you can actually broadcast, like how Android does it. They have like a little mDNS service, like a service discovery thing in there. And so you can broadcast the service, and then Android Studio automatically picks it up and does all the tunneling for you. I haven't managed to get that all wired up yet because there aren't any docs for it. And I was just like reading through a lot of Dart code, and I couldn't quite grep what was going on. And, I already had a working solution, so I sort of tabled it for now. But that's like a further improvement that I want to make, such that you don't have to paste in that URL. You can just do it automatically. It'll just discover it.
Okay. Yeah, that makes sense. I was always curious why, like with VS Code, like I had to do a little bit more, I felt like, as opposed to with Android Studio, I just click play and everything just connected. But now that makes sense. It's using mDNS underneath the hood.
Yeah, there's like a little service discovery system that's built in. And the cool thing about Flutter is how most of Flutter is implemented in Dart. And actually just Dart in general. Most of Dart is implemented in Dart. And so it's sort of the same thing as Elixir, where you don't have to know a bunch of C. You don't have to be like super knowledgeable about low-level programming languages to understand what's going on in the VM, because most of it is written in itself. And so it's us normal non-embedded developers or non-C programmers can kind of understand what's going on. You can see the implementation of, the mDNS client and things like that. And most of it sort of makes sense if you, close one eye, squint a little bit, you can sort of see what's going on.
Yeah, I remember reading something or hearing something about that, where I think they actually switched from C and C++ to Dart because, when you serialize back and forth between different languages, it definitely gives you a cost, right? And Dart is already really fast as it is. So they were just like, we can make big speed improvements by just rewriting the stuff in Dart and just relying on the AOT to make it quick. Yeah.
Yeah, that's sort of something I like about a lot of the recent programming languages like Rust and Go, and now Dart is I guess everything, since it's using like LLVM under the hood, it's all like you can pretty much make whatever language you want, and it's just automatically fast due to how the compiler works. And I think that's sort of a really neat thing that we're seeing a lot. It seems like there's a resurgence of kind of write your code in whatever language you want, and it'll just work kind of situations going on. And that's a lot of what's going on here. Another cool thing about how Dart works, or how I guess Flutter works. I'm not sure which one is responsible for this, but you can, like, when you're ready to put this in production, for example, you'll compile your Flutter application into like it compiles down to like a single shared object file, like on Linux, or I guess on Mac it's like or on Windows it would be like a .dll, .so on Linux and Mac, I suppose. And the Flutter engine just loads that, and it's all like, ahead of time compiled and all of that fancy stuff. And so it's really fast. And that was one of the requirements for the Elixir Nerves Flutter integration, was to have like the production ready app bundles all in that single shared object file, and you can just load it right up. And that's a really cool thing that the Flutter engine does that I've not seen any other sort of app framework do.
Yeah, actually, what I'm kind of curious is, I think I was understanding this is that Dart actually uses LLVM underneath the hood to kind of do the AOT. Is that right? Okay. I was always curious how it could do it.
That is correct. I'm not actually like an expert on how it works under the hood, so pardon me if I get like some of the details wrong, but a lot of the magic that's happening under the hood is all based on the CLang compiler and all that stuff that Google's been pushing forward for the last handful of years. It sort of feels like it's all kind of culminated, like it all ended up at this point of being able to get Dart running pretty much anywhere. Like the Dart VM can run on essentially anything that has like an LLVM backend for, which is really cool. I think it's the same way that Rust works under the hood as well.
Yeah, I was always kind of curious about how Dart can basically compile to anything out there. So basically LLVM is like the secret sauce that helps make it work.
Yeah, that's the magic. And it's sort of a battle to work with if you're working around it. So like, for example, in Nerves, we publish all of our own tool chains, and they're all based on GCC. And we use a project called BuildRoot to build like the root file system and such. And so all of that is sort of like, for lack of a better word, like the old school way of doing it. And that's not necessarily like with a negative connotation or anything. It's just like what it is. But like LLVM and CLang and the CMake kind of tool set around it is sort of like, it's not really pluggable by design. And so that was sort of like a fight for us. We had a hard time using our cross compiler to compile the Flutter engine itself, just because it's not an LLVM compiler. It's not made to do this. And so that was sort of like a hurdle that we had to like kind of climb through. The cool thing about that is Google just publishes precompiled binaries of the engine. So I don't know if you've ever compiled the Flutter engine from source. It's a pain. It sucks. They have decent docs for it, to get it, like if you want to compile it for your Mac or whatever. But if you want to cross compile it, they essentially just tell you, you just use the CLang cross compiler system, and then you go and look up the CLang cross compiler system, and like the docs for it all are like, you should already know how to do this. And so it's like super not user friendly if you were not already familiar with this stuff. It basically just tells you that you need to know how to do it before you do it. And that's just like the docs. And unfortunately, that was just like, we probably burned like a week just trying to get the engine to compile with the right flags and with the right paths and the right sysroots and things of the sort. And eventually just sort of folded and we use the precompiled version of the Flutter engine, just because of how much work it is to compile the engine. And then like the other thing about it is when you actually do get the engine to compile, it takes like 2 hours to run on my machine. I've got a fast machine. And so it's just like, I guess the exchange for all of your, like that really snappy development experience is that you have to compile everything into the engine. And that's the part that takes forever.
Yeah, that makes sense. Okay, that's interesting. Yeah, so I know GCC and LLVM, they're always like kind of at odds. People always say it's this one or that one. Which one do you use? And
Yeah, I think
but it seems like
the thing about LLVM is that like the idea is that it doesn't matter what the thing that compiled the host is. LLVM should be able to target that. Like it links in like the C standard library and all of the world that you might need, and it's really good at being able to tell like all of the things you need up front before you like deploy, for lack of a better word, before you put it on your target platform. And so it's able to kind of assemble everything it needs beforehand. And meanwhile, GCC, like when you compile something in GCC, you got to make sure you've got the same, like the correct C standard library, C++ runtime, and all that stuff. So yeah, they sort of are maybe opposites, opposing sort of concepts that accomplish the same task. And I've found that trying to combine them together can sometimes be a pain.
Okay, that's interesting. That's good for you to hear that. Like I always hear people saying it's GCC versus LLVM, which one's faster? And they say GCC is faster, but LLVM is catching up. And like GCC is kind of a little bit slow to evolve, where LLVM kind of came out of the gates rocking because I think Apple was pushing it.
Yeah, that's sort of been my experience as well. I don't really have any like direct speed comparisons of either compile or runtime, but I do know that like when LLVM works, it works really well. I mean, like that's how you get Rust running anywhere. That's how Go gets, their really small binaries that you can run everywhere. Like you just can't do it with GCC without like jumping through a bunch of hoops. And as much as I love, GCC, it's near and dear to my heart. It's, the new C compiler. It's what everything in the world is based on. I think LLVM definitely is like catching up. We're seeing this resurgence of one compiler to write everywhere, or to write code that works everywhere. And it's really cool. I like that. I like that all of the tools that I download now are, I can download the exact same file and it runs on my Mac machine and my Linux machine. It's just like everything is out there working correctly, and it's pretty cool.
So why do you guys stick with GCC rather than, it seems like you're starting to kind of like LLVM? Like what's the point?
Oh, it's so much simpler. GCC, like they're like, when you don't need to run everywhere, it's just way easier to work, to reason about in your head. You don't have to worry about backends and compilers and all of the 1,000,006 flags that you have to set to get, like, just to get the Flutter engine to compile. Like you have to have like this like command that's like, 14 lines long with like, breaks in it and everything, just because all of the requirements that you have to set up beforehand. You have to tell it where your sysroot is. You have to tell it where the C cross compiler is, the whole 9 yards. GCC is just GCC file -o output. That's it. That's all you have to give it. And so that's sort of the nerves. Our thing is just like the bare minimum that you are required to get started, or to get your application running. And that's sort of our philosophy with everything is, if it's not absolutely required, we don't put it in there. You can add it yourself if you want, but we just have the bare minimum. And that, like, if you ever used Raspberry Pi before, you might notice that like it takes forever to boot, and that's like everyone's biggest complaints, right? Like, oh, I would never put this in production. Debian takes 15 minutes to come up and running. And with Nerves, we have like 10 seconds is like probably our slow speed. Like on the Raspberry Pi 4, you probably got 10 seconds before your app is up. And that's like, magnitudes of different from the stock Debian installation that you get on Raspberry Pi.
Yeah, so I kind of want to talk a little bit more about like the comparison between, using Flutter with other kind of things. So I tried playing with Nerves a few years back, and like I think the best thing that was out there was you would take Phoenix, which is like the Rails of Elixir, And then you could also embed like a WebKit browser to get this thing going.
Yeah, that's still really popular. There's a handful of companies that are doing that out in production. It's not my favorite, but when you don't have a lot of options, I guess you can't talk too much smack about it when the web really is just like the lowest common denominator when it comes to like both getting started and finding developers these days. Like if you want someone to make an application, the developer pool that you could pull from is so huge when it comes to web stuff. The tooling is massive. So yeah, it's really easy just to like, especially with like the new Phoenix Live View, which is a thing that everyone loves. It's a really cool project. The server side rendering. It does all of the magic behind the scenes. It abstracts away all of the JavaScript and all of the things, and you just get to write Elixir, and it makes like progressive web apps, and it's really cool. But I find it to be just like a massive hammer for a tiny little nail. If you're making a thermostat, for example, that's like where this all started. You have a 10 megabyte JavaScript file for a thermostat, right? It's a single circle with a single text box that says 70 degrees on it. And right, you've got a whole web stack just for that. And so that was sort of the appeal of Flutter to me, is like, you've got the engine, you've got all of the tools that Dart gives you, you got all of the magic that it does for you. And it compiles down to like this single tiny little file that you just throw inside your application, and it's completely isolated. It runs in its own little process. And if it crashes, it will just turn it back on again. But it doesn't bring down the whole device. And it's just like this really neat replacement, in my opinion, compared to like the web stack that you get when you bring in all of Phoenix and all that.
I'm curious about what's like the resource use of this, because I think WebKit was kind of a little bit of a pain to kind of get running.
Yeah, that's
it seemed like there's a lot of stuff too, right? It's really much smaller, right? And also, how about running the app itself? It's really efficient.
The Flutter engine itself is very very kind to the system. The Raspberry Pi the Raspberry Pi 4 at least, is a pretty beefy device as far as embedded goes. Usually you're in like the 1 gigahertz range with maybe 512 megs of RAM or so, like kind of like maybe comparable to like a gingerbread Android phone from 2015 or so. That's sort of where most embedded devices live, I would say. So the Raspberry Pi 4 is maybe more powerful than that, right? You get I think the base model Raspberry Pi 4 comes with either 2 or 4 gigs of RAM and 4 cores and all that. So it's a small computer more than it is an embedded device. But either way, the Flutter engine is very kind to that device. It's made to work with multiple CPUs. It's sort of from the ground up developed for that task, rather than a web browser, which was designed back when devices had one CPU and memory is kind of expendable, right? Like you're used to your web browser taking up all of your system's resources, and that's sort of not what we want in an embedded device, right? Like it's got to run alongside all of the stuff that it's actually meant to be doing, like controlling your HVAC system or whatever. So yeah, the Flutter engine is undoubtedly much more efficient than just running your web browser. And that's not to say anything bad about the web browser. I think it's just they're designed for two different tasks.
So what was the outcome, right? So how much time you spent, and then what was the decision after the end of your run?
Yeah, so I think I spent probably a month on this, and I got it to a place where anyone who is using Nerves can probably, or anyone who's using Nerves on a Raspberry Pi 4 specifically, can go use this today. I gave a talk on it not that long ago at the first Nerves Conf a couple weeks ago. I don't know if videos are up from that yet, but if they are, we should link them. And it's really easy to get started. You basically call the mix. There's an analogous to Flutter create in Nerves. We call it mix nerves.new, and it generates the whole project for you. And then you can get that code running on the device, and that's really straightforward and like a really well documented process. And then you just add as a dependency, as a side loaded or as a package, you add the Elixir Flutter embedder and point it to your Flutter app. I guess the one thing that sort of is unfortunate about it is I was doing all this work right before the null safety update to Flutter. And so I haven't got around to updating it to that update yet. So a lot of the Flutter dependencies that you can use from like flutter.dev or whatever the package manager is for Dart, you have to go back to whatever the last release before the null safety update was, because they're incompatible. They made like a binary breaking change. And so that's something it's been like high on my list of stuff to fix. I just haven't been able to get someone to pay me to do it. But that's probably the only caveat, I guess. But other than that, it's still super, super easy to get started. And as far as like where it's at right now, it's out there. It's open source. It's ready to be kind of used, but it definitely, I won't say it's like a perfect experience. You're going to have to like sort of know what you want to accomplish with it. It's not just like, I won't say that you can just like casually go put an app out into production. It's not quite that easy, but it's pretty close to being like a really good project, I'd say. And I think right now, SmartRent, the company I was working for, they sort of had a little bit of a priority shift. I think they deprioritized the project that they were starting on because of COVID, because of the chip shortage. There's just like a global silicon shortage right now, and that sort of affected them. So they've kind of got it on the back burner for the time being, but I expect that it should be picking back up at some point in the relatively near future, I'd say.
Okay, so I had an impression that maybe they because I think you said before like they're going another direction, but I thought that meant like it wasn't fit for their needs or something. But you're saying that it's actually fit their needs and working pretty well, but just because of the chip shortage, that's why they have to shift for temporarily, it sounds like.
Yeah, that's just sort of like a lot of the world is being affected by this right now. It's sort of like a big deal in the embedded space. There's a lot of people that are having just like real trouble getting their devices out to production because you can't get all of the stuff that you need right now because of that. Car manufacturers and such are taking up all of the resources for the rest of the world, and it just is like that for the time being. But no, the project seems to have landed pretty well with the developers that we tested it with. Frank Hunleth is another one. He's the creator of Nerves, and I let him play with it. He had a good old time playing with it. The core is rock solid, and most of that is due to like the existing Flutter tooling. I really didn't like. I don't want to downplay any of my own work or anything because, like it was a lot of work, but I think that like if anyone really set their mind to it, they probably could have accomplished it. It's pretty straightforward, the actual implementation of porting the Flutter engine, as long as you know what you're doing and you have like a goal set in mind.
Yeah, we had a guest on here. We talked before the show. He ported Flutter to the TvOS, which I think is pretty interesting. He acted like it was pretty simple, but as you said before, it's not necessarily simple, but also not really difficult. It just takes a lot of time reading and trying, and I'm guessing.
Yeah, I think a lot of it, for me at least, a lot of it was just getting like that. For me, anything like this, any of these sort of like traditionally difficult tasks is just getting the development cycle as fast as possible. And so that's where of course I'm on the nerves core team, so I kind of know all the ins and outs. I know all of the escape hatches of how you can kind of abuse the system for a little bit more developer focused speed. And so that's what it was for me. I was just hammering away at it, just like as quickly as possible, reloading and reasserting that I know what I've got going on here. But as far as the implementation goes, you really just implement a bunch of callbacks for the Flutter engine. They sort of built this system in from the get-go that people are going to want to run Flutter in embedded, or just like outside of the context of apps, right? Like we see, I think with Flutter 2.5, the Flutter is able to run on the web just like out of the box. Of course, you have to worry about like deploying that, and I don't think they do all of that for you, but like just it runs in Chrome automatically, and it's the same system that I use to run Flutter on an embedded device. They just sort of made this pluggable system from the beginning, and that just makes it really easy. You have to write some C. There's no getting around it. I mean, I'm sure. Okay, yeah, you could do it in Rust, you could do it in Go, any of those other things, and maybe if that's your thing, that works for you. But I know C, so that was where I went with it. And like they give you 6 or 7 callbacks and you implement them, and it works after that, provided you do it correctly.
So once you implement those 6 or 7 callbacks, then basically the rest of the work is already being done by the engine.
Right. Yeah. The Flutter engine does all of the hard work for you. You have to like the callbacks that you get are like allocating memory, setting up OpenGL, setting up device like input, like the touchscreen and anything like that. You have to set all of those things up. So basically all of the things that the Flutter engine just like literally cannot do without a ton of like platform specific code, you have to implement those things. And as it turns out, it's not that many things, right? Like turn on the screen, swap the OpenGL buffers, set up touchscreen. And once you have that, that was like probably my biggest surprise once I went in and like sort of implemented myself all of those callbacks. Like I hit run on the device and it just ran and it worked. And that was sort of like, like here I am just sitting here poking around and it just like worked out of the box. And then, the next step, that was just like getting it on the screen. I'm like, oh, that's really cool. But I can't do anything because I didn't have the touchscreen set up. So I set up the touchscreen, and then like all of the Flutter stuff just automatically worked. I could do HTTP requests. I could load images from the web. I could do all of that fancy, like all of the stuff that you could do on Android or iOS natively just automatically worked out of the box.
That's really powerful.
That's what it felt like to me. It felt like is one of those superpower moments where, at the end of all of this work, I just had this like it felt like a native device basically. There are some Flutter pub, like pub.dev or whatever applications that don't have, like the NFC library. Of course, that didn't work because I didn't wire up NFC. That was one that, I've been playing with that a little bit. I've been, on a side project. I use the NFC library. And that was one that I like sort of half wired up to get to work. And then like the Bluetooth one, of course, that didn't work. So anything that uses any native code under the hood, doesn't work. But the overwhelming majority of Flutter packages just automatically work.
Yeah, that's actually the last thing I'm thinking about is like for all these packages, it's always like, okay, we support like Mac OS, iOS, Android. So like if you're implementing the Flutter engine, like how can you have something like this?
You mean like on Flutter Pub or on like pub.dev where it shows like Mac OS, Linux, like all the different platforms?
So let's say for Nerves you want to implement like the Bluetooth or Wi-Fi, something like that, right? How would you, do you actually have any idea how you can implement something like this for Nerves?
Yeah, so that was sort of like the last section of work that I did for this before I kind of like released it out into the world is Flutter's got this really cool system. This is another thing that they sort of just built out of the gate, where they knew you were going to have to write native code, right? So, when you generate a new Flutter app and you need to get the battery level, right? Like you have to write like this little snippet of code in Swift, and then you have to write a little snippet of code in whatever Java's thing is, or Kotlin now, right? And so now on this, on the Flutter embedder for Elixir, you have to write that same little snippet of code in Elixir. And so it's just another target that you have to write. And I wired up all of the things behind the hood to make that happen. I had to implement Dart's native like binary protocol, like the implementation of integer and floats, double, etc. I had to implement all of that in Elixir, such that you get kind of native implementation just works out of the box. But yeah, that's all it is. You just you use Flutter's platform channel, I believe is the name of the system. And I'm sure seasoned Flutter developers have probably used it before. And it's the same thing. And you write like your app / get battery level, and then you implement that in Elixir and you just return a float that is your battery level or whatever your application needs. And so I've implemented a Bluetooth application using the Elixir Bluetooth stack called Blue Heron. That's sort of our Bluetooth stack, and you can sort of just pretend that it's not there, right? You have your Elixir dev or whatever. You can implement it. Your Elixir developers can implement it. Someone does. And then your Flutter code just wraps it, and it just works out of the box as well.
Oh, okay. And actually, this should be pretty simple to do because, like, I think the binary matching and stuff.
Yeah, it was so easy. That was my funnest part of the project for me. That's just like something I get really excited about when I get to use it or Erlang in Elixir. The binary protocol or the binary pattern matching is really fun to use and feels like a superpower. But it took about a day to implement that and get that all up and running. But it was really fun, actually.
Yeah. I was just thinking, like, maybe like one of my last questions, because we're kind of approaching the end of our time, is like, if you could implement this as for the different platforms, right? This is probably not easy to do because like every nervous device has different kinds of CPUs and stuff, right? So is that something that's actually possible to do, where you can say, okay, if you want to add Flutter to your existing, Raspberry Pi, Big Bone Black, or whatever different kind of system you have, is that like simple to do, or that really takes some time to do?
I think it depends on how you go about it. For example, Bluetooth, that's something you think that is going to be like different per device, right? But we use Linux under the hood. So what I do, or what I think the happy path is for this, that maybe some people might disagree, but for me, at least the way that I've designed everything to work is that you implement it in Elixir, not per your target CPU or per whatever. So Elixir, you're going to have to like jump through several different like hoops to get there, but you get it in the end. So you start from Flutter, say at the very top, you want to connect to a Bluetooth LE device. So you use Flutter's platform channels. So you can have like your Flutter application looks the same no matter what. Like you can deploy the same application on Android, on iOS, or on Nerves. And it like you don't have to write any different code. And then it uses Flutter's platform channel under the hood. So on Android, you write a little Kotlin wrapper around your Bluetooth LE code. On iOS, you write a little Swift wrapper. And then on Nerves, you write a little Elixir wrapper. And then on Nerves, you go another step deeper, and there's already a package out there for Bluetooth. So you just use the existing Bluetooth package. And it itself uses Linux under the hood. And then Linux abstracts all of the platform-specific code out from you via its module system or whatever. So there's like a lot of hops you have to do. And that's the same thing that Android does, right? Like when you write the little Kotlin wrapper, you're using the Android wrapper around the Linux wrapper as well. You're doing the same thing. It's just another package that you have to use, another external dependency. Yours just happens to be part of the Android OS. So in our case for nerves, you're using a package called Blue Heron is our Bluetooth library name. And it does all of the management for Linux under the hood for you. So yeah, you just sort of have to hop through your chain of dependencies to get there. And maybe some people don't like that concept, but it's something that works really well. And I think is really powerful in terms of, like how Flutter works. I really like the experience on how you write platform specific code with Flutter like that.
I'm just thinking about like if I wanted to, because I don't have a Raspberry Pi 4, I think I have a 3B or something. Like if I want to get that running, then it's not really possible, right? Because what you're saying is that you only got it running on Raspberry Pi 4 in particular, right?
Oh, yeah. So that requirement isn't actually just because like there's something Raspberry Pi 4 specific. Raspberry Pi 4 is just the only Raspberry Pi that allows you to set up OpenGL in the way that it does due to a change that they made in the silicon. You probably could get Flutter running on the Raspberry Pi 3B, but you'd have to like sort of dig into a bunch of Raspberry Pi specific things. The reason I went with Raspberry Pi 4 specifically is because it uses the generic Linux route. So any modern device is going to set up OpenGL in a particular way. And it uses a set of standard OpenGL calls that use a system. It uses a system on Linux called, oh man, I can't remember the name of it now. But anyways, there's this new system for opening frame buffer devices on Linux now. And so any system that uses that same, or any device that uses that same system, then the Elixir Flutter embedder will work on. So BeagleBone Black supports it. Raspberry Pi 4 supports it. The chip I was talking about earlier called the OSD32 MP1, it supports it. We haven't tested it and got it up and running, but basically any modern Linux device should work with it. And I think the Raspberry Pi Foundation is slowly working on backporting it to the Raspberry Pi 3. The Raspberry Pi Zero doesn't have the graphics accelerator chip that it doesn't have the correct OpenGL setup. So you can't, like, even if you really wanted to, you couldn't run Flutter on a Raspberry Pi Zero, I don't think. I may be wrong. Someone may be like firing up their keyboard right now about it and telling me how wrong I am, but I'm pretty sure that the CPU itself just doesn't have the right graphics chip. And so it's not necessarily that it's specific to Raspberry Pi 4. It should work on any modern Linux device that supports the new Linux frame buffer system. And by extension of that, that means that like for a lot of the development of this process, I used just my desktop computer. I didn't even use the Raspberry Pi 4 at all. I ran it locally on my Linux machine. And that just worked.
Okay, so once you kind of got working on your local machine, then you're saying that that's kind of almost enough for this to work on Raspberry Pi?
Correct. Yeah, just due to the new how the application opens the like connection to your graphics card, for example. They sort of made this one unified interface for it. The Linux kernel did, and it's kind of a pain because of how generic it is. You have to jump through a handful of hoops to make it work. But ideally, anything that uses this new system, so any modern x86 machine, and then like a lot of the new ARM devices that are coming out are also using the same system because of how generic it is. It's pretty simple to implement. Yeah, anything that uses it should just work out of the box, supposedly.
And I was just thinking, like, because you're already using a piece of Linux as it is underneath for nerves, and there's already like desktop support for Linux in Flutter anyways. So, like, is there really a lot of work to even do to really make this thing better for nerves?
That was sort of like my very first hope, was that I could just use the desktop Flutter embedder. It didn't quite work out because of how many dependencies it uses. The Linux version uses GTK, which is a really powerful framework, and it is what it is, but it's a heavy dependency, and it requires something else to do all the mode setting and all the other magic that happens to bring up a frame buffer on a Linux device. So I wanted to use it because, like, of course, it's already done, right? Like, I wouldn't have had to write any code if that were the case. But it didn't work out that way because of how heavy the dependencies are. The Elixir one, or the Nerves one specifically, is in standard Nerves philosophy the bare minimum that you need to get up and running. It brings up the frame buffer, and it opens an OpenGL context, and then it lets the Flutter engine do all the rest of the work.
I would really love to see, what Toyota's working on, because obviously they're in a similar boat.
I missed that when I was like, the initial pass on this was just like spend a week looking for existing implementations and hope that I can find something that I can use as a pluggable interface rather than write a bunch of code myself, right? Like that was the dream. And I missed the Toyota one. It either wasn't published yet, or I just missed it somehow. And I found it. Someone linked it to me afterward, like after I was already done with the work. Someone sent it to me, and I was like, "No, this is exactly what I wanted." So that's something I want to actually go back and look at and see if it's something I can use, because it looks like they did the same thing that I did, just more generically. It's not specifically for Elixir, obviously. And so I would love to be able to just take all of the Toyota connected stuff and then just plug in my Elixir interface to it, and then not have to do all of the frame buffer device overlay stuff myself, basically. That would be really cool.
Yeah, so maybe if you ever get some more funding, you could work more on trying to get that one going. I don't know, because I'm sure they probably support the null safety, because that sounds like a pain to do.
Yeah, that's been a hurdle for me that I just haven't had time really to go update to the latest. I think it was like Flutter. Was it? I can't remember the version numbers off the top of my head, but I think we're using like a 1 point something, and then the null safety update was at 2.0. How that worked.
Yeah, that was like forever ago, I feel like.
Yeah, that's what it seems like to me. I keep on calling it the new update, but I guess it's not new anymore. It's just new to me because I don't do this stuff every day.
No. But I really appreciate you taking so much time to talk about this, and it's been super enlightening. Like, I think I never knew that how Dart kind of worked, but it's using LLVM underneath, which makes a lot more sense to me. Cool. Like, is there anything else you wanted to say before we kind of sign off for this session?
I don't think anything I want to say. If anything, I want to plug Nerves Framework. Go check it out if you've got any need for embedded devices. It's a really rock solid platform to build new IoT type devices on. And
of course, please sponsor you to continue your efforts on bringing Flutter to Nerves.
Yeah, give me more money. I'll put Flutter wherever you want.
Yeah, sounds exciting. I really would love to have this. Okay, thank you for taking the time to join us, and I hope you're feeling much better.
Yeah, thanks so much.